probability, and we're going to talk about something called simple probability. It's called simple because it's basically the beginning of probability. Simple probability consists of only one event. I'm going to flip a coin. What's the probability of being heads or tails? I'm going to roll one die. What's the probability of being a 4? This is calculated by dividing the number of outcomes over the number of possible outcomes. So if I want to flip tails, you have one outcome. Tails is successful. You have two possible outcomes, so that the probability of getting tails would be 1 over 2, or 50%. All right, probability can be given as fractions, decimals, or percents. In this class, we will strictly use fractions. You can, on your own, put it as percentages if it makes more sense to you, but a lot of times we just use fractions because then we can actually see what's happening. All right, so example number 1 is Bobby's rolling a 6-sided die. What is the probability P that he will roll a 2? That is read as probability 2. So we're going to use a lot of these cap P's and whatever we're looking for. So in this case, it'll be probability that he rolls a 2 is going to equal the number of outcomes that result how he wants to. How many outcomes actually are what he wants? Ross? 1. There's only 1 2 on a die. So that would be 1 outcome works. How many possible outcomes are there? Ross? 6. So your probability of rolling a 2 is just 1 over 6. So if you roll a die 6 times, you're more than likely to roll a 2. Not definite. These are all percentages. But if you roll 6 times, you're more than likely to come up with a 2. That's what the odds say. All right, example 2, it says find the probability of observing a number larger than 4 when rolling a single die. So I'd write that as probability of maybe larger than 4. How many numbers on a die are larger than 4? 2. And those are 5 and 6. 5 and 6 are the only 2 on a die that would be larger than 4. So this probability is going to be 2 over 6, or 1 over 3. That 2 comes from 5 and 6. Sometimes probability can just be counted, just like we did with the dice. Sometimes when I ask you to roll 2 dice, you can actually come up with a whole number of your possibilities. Well, in this case, it says find the probability of observing a sum of 5 when a pair of dice is rolled. Most of the time, you wouldn't write this out. Most of the time, you just think in your head. All right, we could roll a 1 and a 4, and you can roll a 2 and a 3. However, order matters when you roll a dice. A 1 and a 4 is different than a 4 and a 1, so you have to count those as 2. A 2 and a 3 and a 3 and a 2 also count, so you should end up with 4. And if you look at this, if you circle every one of them that adds up to 5, so that would be 4, 1, 3, 2, 2, 3, and 1, 4, you'd see there's 4 different ways to roll a 5. So that means our observation would be our probability of our sum of 5 is going to equal, well, there's 4 outcomes over how many possible outcomes? 36. It'd be 36. There are 6 outcomes from the first die, and there's 6 possible outcomes for the second one, so it'd be 6 times 6, which would equal 36. There's 36 individual ones. So that's 4 divided by 36, which we could reduce down to 1 over 9er. All right, last one on simple probability, because simple probability is kind of boring. It's just counting. Example number 4 is find the probability that you will roll a 6 and then a 5 when you roll a die twice. How many of those outcomes up above are you roll a 6 and then you roll a 5? It's just 1. It tells you the only outcome you can have. You have to roll a 6 on the first one, and you have to roll a 5 on the second one. There's only one of those outcomes up here. It is right here, a 6 and then a 5. Yeah?
1/36.
1 over 36, yes. There's only one, that's 6 and then 5, and there's 36 possible outcomes. Note, I could change this question a little bit to say, what's the probability of rolling a 6 and a 5? That would make that 2 over 36 because it doesn't say what specific order it has to happen. 5 and 6 would work on that as well. So make sure when you're looking at pairs of items, you see if both of them count or if only one of them counts. In this case, only a 6 followed by a 5 works. All right, let's get into compound probability. Compound probability results when you have more than one event happening. So it's a calculation to determine the likelihood of 2 or more independent or dependent events occurring. So we need to talk about what it means to be independent and what it means to be dependent. Independent. An independent event are 2 events that happen independent of each other. In other words, they do not have an effect on each other. The example is rolling a 6 and then rolling a 5. If you roll a 6, it has no bearing on your next roll. It has no effect on it. The shortcut to writing is this. This says the probability of event A and event B happening. So that little upside down U is a shortcut for and. And to calculate that, you just take the probability of your first event and multiply it by the probability of the second event. So in this case, the probability of rolling a 6 would be 1 over 6. The probability of rolling a 5 would be 1 over 6. So that would equal 1 over 36. Well, that's what we came up on the other side. The next one is dependent. Dependent means one of the events is affected by what happened in the other event. So outcomes of the first event does affect the outcome of the second event. So if we look at this example, it says, without replacing the first card, choosing an ace and then choosing a king. So when I'm choosing an ace, there are 4 aces in a deck of 52 cards. We're not counting jokers. So that means to pull out an ace, we would have 4 over 52. We aren't replacing cards. That means there's no longer 52 cards in that deck. I pulled one out, it was an ace. So now there are 51 cards in that deck. So my next probability would be over 51. However, there are still 4 kings in there, so it would be 4 over 52 times 4 over 51. And that's what this is saying. If you're doing a probability of event A and event B happening, where B is affected by A, you're going to write the probability of A times the probability of B following the actions of A. Actions of A pulled 1 card out, so I have 1 less card, but I still have the same number of kings in there. Yes, Emma?
Where did you get the 4?
I got the 4 because there's 4 aces in a deck of cards.
Oh, okay.
So this is the number of aces, 4 aces, over 52 cards in a deck. Minus jokers, but we're not going to have jokers in it. And this is 4 kings over, well, now there's only 51 cards in that deck. Because 1 was pulled out and you're holding it. You're holding that card. It can no longer be part of your probability. We'll do some more concrete examples down below. All right, so the first example is find the probability that you will roll a 6 and then a 5. Well, we just did that. We just did that, but the first thing I'm going to put in here, just a little more elaborate, is this is in fact independent. It is independent, and so what we're going to do is we're going to do the probability of rolling a 6 times the probability of rolling a 5. The probability of rolling a 6 we said was 1 over 6. The probability of rolling a 5 is also 1 over 6. Multiplied is 1 over 36. That is the 3rd time we calculated that. Super fun. All right, our next one will be dependent, though. You have a bag of marbles. 3 of them are red, 2 of them are green, and 4 of them are blue. This says you're going to pull out 2 marbles. What's the probability that both of them are blue? So that means without, and it says without replacement. That's the big thing. So I'm going to pull out a marble, set it off to the side, and I'm going to pull out another marble. That is, at the core, the definition of dependent. Yes?
If you pull them out at the same time, would it just be...
It's still going to be dependent because it's dependent on what the other one is. We're going to treat it as individual. Even when you pull two out.
I got that wrong.
Most of the time, this problem's set up to be a 1 and then the other one. Because depending on what one of them was, you have to account for what the other one is that affects the other one. So treat it as a single case. So in this case, it is definitely going to be dependent because they're dependent on what the other color is. So let's talk about the first marble. So our probability of our first blue marble. The probability of my first blue marble is, well, there's 4 possible blue marbles to pull out. So that's 4. 4 possible blue marbles. And that's going to be out of 9 total marbles. So there's 4 blue. There are 9 marbles. All right, the probability of my second one being blue is affected by that first one. How many marbles are in that bag? Yeah, there's 8 marbles in that bag now. So that's 1 less marble. How many blue ones are in the bag? Yeah, 3 of them. So that is also 1 less marble. Because I pulled out a blue one, so I have 1 less blue, and I have 1 less total marble. So that is the probability of my first thing happening times the probability of my second one happening being affected by the first thing. Yes?
But you don't know which marble is 2.
Well,
Or blue.
I'm saying I have a 4 in 9 chance of getting a blue marble in the first one. And here's the chance, if I would pull out a blue marble, what's the chance of the second one being blue? So when I multiply them together, I am saying that what are the chances of them both being successfully blue? I get what you're saying, though, because it's a little complicated. Because like, but what if it wasn't blue? Well, that's handled by that 5 over 9. All right, so this is going to be... Oh, sorry, yeah. So if me pulling out 4 out of 9 is my blue, that means 5 over 9 would be no blue for my first one. We'll talk more about that on Monday. But this is going to be 12 over 72, which reduces down to 1 over 6. So in order, this does tackle that issue of what if it wasn't blue. It is saying, this is the probability of my first one being blue. If it is blue, here's my probability of my second one being blue. Multiply it. That is the probability of them both being blue. That I successfully pulled that first one blue, and I successfully pulled the second one blue. All right. So that's a dependent there. Last one's more of a cheeky problem than anything else. A couple has just given birth to a baby girl. What is the probability that their next 2 children will also be girls? Yes? Whatever you raise your hand for. It'd be 1/4. It would. Are children dependent on the other one? So if your parents have a boy, same 50-50 to have a boy the next time. 50-50 to have a boy the next time. So your second, maybe I should put it as a probability. Probability of a second girl would be 1 out of 2, 50-50. 1 girl versus a boy or a girl. The probability of your third girl is once again 1 over 2. These are independent. So we'd multiply together, and they would equal, like Ross said, 1 over 4. What if the first child was a boy? Then what would the probability of all their kids being girls? 0%. Because the first one was a boy. I was waiting for someone to go 1/4.
Well,
There we go. All right. That is probability in a nutshell. That is... Yeah, she tells her probability teacher. You have plenty of time to start your homework and get a good jump on it. Some of these are more complicated.